Hello there. In this video we're going to discuss how to solve polynomial equations and polynomial inequalities by using all the techniques that we have discussed up to this point. So for example, we're going to be solving things such as, solve for all values of x, such that x cubed minus 2x squared plus 9x minus 18 is equal to 0. We're going to be looking at equations like this and ones that are a little bit more sophisticated, and also how to solve inequalities of this form as well. So to begin, first notice that this is a cubic equation, and up to this point we have not discussed a closed form representation on how to solve this using any particular formula. So one of the most easiest ways to solve cubic equations, if it's possible, is factoring by grouping. So if we can factor this by grouping, then the solution method is going to be easy because we're going to have a linear factor and a quadratic, and then we can use quadratic formula on the remainder if we need to. So first off, I'm going to group the first two and the last two terms together. So I'm going to pull out an x squared out of the first two terms, leaving us with x minus 2. Plus, I'm going to pull out a 9 out of the last two terms, leaving us with x minus 2. And notice that x minus 2 is in common with both. So I can pull out an x minus 2 out of both terms, leaving us with x squared plus 9 is equal to 0. I know how to factor an x squared plus 9 term because that's just the sum of squares. So this is just going to factor into x minus 3 times x plus 3i times x minus 3i, and that's going to be equal to 0. So this equation is extremely easy to solve, therefore we can finish and say that x is equal to 2, 3i, and minus 3i. That should read as 2. So these are my solutions, all complex solutions, of my original cubic equation. So let's look at another cubic equation. So let's solve x cubed minus 2x squared minus 5x plus 6 is equal to 0. So this is an example that you cannot, at least directly, use factoring by grouping to factor. Because notice that if we take out an x squared out of the first two terms, I'm just left with x squared times x minus 2, and 5 and 6 do not have a common integer factor. So one thing we can do is sort of look at the coefficients. So notice that we have 1 minus 2 minus 5 plus 6. And we know that 1 minus 2 minus 5 plus 6 is equal to 0. So if we just look at the coefficients, we can see that if we plug in 1, then this is going to be a solution. So x equals 1 is going to be a solution, implying that x minus 1 is going to be a factor of this expression. So I'm going to use synthetic division to figure out what I'm going to be left with in that expression. So I'm going to plug in 1, and I'm going to have 1 minus 2 minus 5 and 6 as my coefficients. So I'm going to bring down 1. 1 times 1 is 1, negative 2 plus 1 is negative 1. 1 times negative 1 is negative 1, and negative 5 plus negative 1 is negative 6. 1 times negative 6 is minus 6, and that gives us 0, as we already know. So if that is the case, that means x cubed minus 2x squared minus 5x plus 6 factors into x minus 1 times, remember, these are the coefficients of my quotient quadratic, namely x squared minus x minus 6. So now my goal is to factor that if possible, because we still need to solve this, set this equal to 0. So we should know that this factors into something nicely. So two numbers multiplying to get negative 6 and add to getting negative 1. That's going to be x minus 3 and x plus 2. So now our equation is completely factored. So we can say our three solutions are 1, 3, and minus 2. Again, we're going to revisit cubic equations in a little bit more detail later, so we'll just assume that we can sort of see one solution, find the other two, or maybe use factoring by grouping just to get it in factored form from the start. So now let us shift our focus to inequalities. So let us find all values of x such that x cubed minus 2x squared minus 5x plus 6 is less than 0. So now we're going to be looking for intervals of x that make this true. So already we have factored this expression. So we've shown that this is the same as x minus 1 times x minus 3 times x plus 2 is less than 0. So when you want to solve polynomial inequalities, the first thing you should try to do is factor the expression when it's set equal to 0. So now I'm going to employ our graphical skills from before. So remember, this is a degree 3 polynomial with an odd degree and positive leading coefficient, and it has x-intercepts of 3, -2, and 1. So we know the graph of this polynomial is going to have this type of shape. So from the graph, we can automatically tell where the solution, or what x values are going to make this negative. So it's going to be negative on this region and this region here. And remember, we're not going to be including the x-intercepts because we want to know when it's strictly less than 0. Therefore, the solutions to this inequality are going to be minus infinity up to -2, union 1 to 3. And that's just based on our graphing skills of polynomials. So as an example, let us assume we have some polynomial expression and we're able to factor it into -3x times x plus 3 cubed times 2x minus 1 squared times x minus 5 to the power 4, and we want to know what values of x will make this greater than or equal to 0. So I'm going to begin by sketching the graph of this polynomial function. So first off, the leading coefficient is going to be what? So this is going to be negative, this is going to be positive, positive, and positive. So the leading coefficient of this polynomial function on the left is going to be less than 0. And my degree is going to be equal to 1 plus 3 plus 2 plus 4. 4 plus 2 is 6 plus 3 is 9 plus 1 is 10. So that's even. So we have an even degree and a leading coefficient that's negative. So therefore the end behavior is going to be the same as -x squared. So with that in mind, let's begin to start to sketch our function of interest. X-axis, y-axis. So our x-intercepts in this case are going to be 0, -3, 1/2, and 5. So let's sketch them out right quick. So 0, -3, 1/2, and 5. So at -3 we have an odd multiplicity, so we're going to pass through that point. We have an odd multiplicity at 0, so we're going to pass through that point. At 1/2 we have an even multiplicity, so we're going to bounce off that point. And at 5 we're going to have an even multiplicity, so we're going to bounce off that point and go to 0. Make sure that this agrees with our multiplicity sketch in the beginning. So we want to know when this curve is greater than or equal to 0. So it's greater than 0 on this little shape here. It's going to be equal to 0 at all of the x-intercepts. So from the graph, we can see that the solution to this inequality is going to be x belongs to the interval -3 to 0, union the set of points 1/2 and 5. So these are just some basic skills that you can use using the skills we have already discussed on how to solve polynomial equations and polynomial inequalities. Hope you enjoyed.